Okay, today is the second day of solving rational equations. So to review, our steps are we factor, get a common denominator, multiply so that we get a common denominator, and solve the numerator of my equation. So in this first example, which you can put on page C in your notebook, is to factor. So that would be 5 over 2 times x minus 1 equals 15 over x plus 1, x minus 1. So now if I compare my two denominators, both of them have an x minus 1, so that's good. But my one on the right is missing a 2, so I need to multiply the right side by 2 over 2. And my left side is missing an x plus 1, so I need to multiply that side by x plus 1 over x plus 1. Now I need to simplify my numerator. So my first fraction I'm going to have to distribute, and that would be 5x plus 5 equals my right side. I need to do, that would be equal to 30. So then if I subtract the 5, I get 25. So 5x equals 25. And I get that my final answer is 5, which will not make my denominator 0, so my solution will work. Going on to this one, 11 over 3x minus 1 over 3 equals negative 4 over x squared. So first I need some common denominators all around. Now, my first two fractions have a 3, so that means I'm going to have to multiply my last one by a 3 over 3. If I look at variables, they have some x's going on, and the highest exponent I have is x squared, so I need to make sure everything else has an x squared. So I need to multiply the first fraction by an x over x, and my second fraction by an x squared over x squared. And that should give me a common denominator of 3x squared all around. So I'm going to write that down. And now let's simplify the numerators. 11x minus x squared minus 12. Now this is a little bit different than what we've seen. If I just write my numerators, 11 minus x squared is negative 12. This is going to be a quadratic, so I'm going to end up factoring this guy. So I'm going to move everything to the right because I have a negative x squared and I want that to be positive. So if I move everything to the right, I get 0 equals x squared. Oops, I left my x off, that's why I'm confused. Minus 11x minus 12. So this would be x factor, what multiplies to negative 12 and adds to negative 11, which probably a lot of you are doing in your head now. So that would give me 0 equals x minus 12 times x plus 1. And if I set x minus 12 equal to 0 and x plus 1 equal to 0, I will get my two solutions, which are 12 and negative 1. Neither of which, if I substitute back into the original, would give me 0 in the denominator. In this next example, it would be helpful to think of these numbers as having a denominator of 1, in which case you can see that I need to get a common denominator of x. So I need to multiply my first fraction by x over x and my second fraction by x over x. Write down your denominator, so something over x plus something over x equals something over x. Simplify your numerator. So x times x is x squared. That just stays 6, and this is negative 5x. So if we just write out our numerator, that would give me x squared plus 6 equals negative 5x. This time I'm going to move the negative 5x over here in the middle so it's in standard form. And that would factor to x plus 2 times x plus 3, which means my two solutions are -2 and -3. Once again, thinking about substituting that back into my denominator, it will not make it 0. It would make it the denominator -2 or -3. So it is perfect, and we're good to go. So my answer is, once again, -2, -3. Both of those should make my equation equal. Next, just like the last problem, first of all, I'm going to think of this as being over 1. And now I can see my common denominator is going to be something with an x plus 1 and a z plus 1 and a z minus 1. So I didn't leave myself enough room. I am going to have to rewrite these. So I have room. You might have left yourself room. Good for you. So my first denominator is z plus 1. My second fraction does not have a z plus 1, so I need to multiply that by z plus 1 over z plus 1. My second one does not have a z plus 1. So z plus 1 over z plus 1. Next I have a z minus 1, but my first one does not have a z minus 1, so I have to multiply that by z minus 1. Obviously my second fraction does, but my last one doesn't. Okay, now all of my denominators are the same. So I can go ahead and write them. While I'm writing this, I'm thinking that I'm not going to be able to have a positive 1 or a negative 1 in my denominator. So those are the two values I can't have in my final solution. So I'm just kind of thinking that. I might, since I'm thinking that, jot it down. Z cannot equal plus or minus 1. Plus or minus, there we go. All right, so now what are my numerators going to equal? 2 times z is 2z. 2 times -1 is -2. 4 times z is 4z. 4 times 1 is 4. And what I want to think of, this right here, z plus 1, z minus 1, is a difference of squares. So this is z squared minus 1. So when I think of distributing my -2 in, that would give me -2 z squared plus 2. So just my numerators would be 2z minus 2. Don't forget to distribute your negative for your next numerator. Minus 4z minus 4 equals -2z squared plus 2. Whoops. All right. So now let's do some combining like terms. That would give me a -2z minus 6 equals -2z squared plus 2. Now, I'm going to just erase my original problem up at the top and move things up there so that I have some room. Okay, so I'm going to move everything to the left side. So that would give me a positive 2z squared minus 2z, and then -6 minus 2 would be a -8. And this makes me happy because I have a GCF of 2, so I can just go ahead and divide everything by 2. So 2z squared minus z minus 4 equals 0. And now, as I look at this, I am oh so sad because my quadratic that is left with is not able to be factored, which means I have to use my quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Notice I just put a positive 1 squared because the negative doesn't really matter when I'm squaring something. So 1 plus 16 over 2. So 1 plus or minus the square root of 17 over 2. Yuck, yuck, yuck. That's my final answer. That is definitely not equal to positive 1 or negative 1. So I know that it will be my solution. Whew. So sometimes we have to use the quadratic formula. That was pretty hideous. Probably won't have one of those on your test. All right, last one. I already have the same denominator in 2 of my fractions, so I'm just going to cut to the chase and multiply 1 by m squared plus 4m minus 5, m squared plus 4m minus 5. Alrighty, so if I just write my numerators, that would be 4 equals 6m plus 18 plus m squared plus 4m minus 5. And for many reasons, I'm just going to subtract that 4 over. And once I combine like terms and get everything in standard form, that would be m squared. 6m plus 4m is 10m. 18 minus 5 is 13, minus another 4 would be 9. And yay, this one does factor to 9, 10, 9 and 1. So 0 equals m plus 9 times m plus 1. So my two solutions are negative 9 and negative 1. Now I need to make sure that neither of those would be excluded. If I factor my denominator here, that would be m plus 5, m minus 1, which would mean I can't have m equal to negative 5 and positive 1, but that's not what I got, so I do have two solutions. So sometimes you are going to have to check, like if I had gotten that this was a positive 1 here, if m equaled negative 9 and positive 1, then I would have to cancel out the positive 1 solution and I would only have one solution of negative 9. So you do always need to check and make sure that you have valid solutions. You don't have any extraneous ones. Thanks for joining today. Answer the couple questions at the bottom.